Welcome. In this tutorial we are going to learn about chain map. It's an updatable view on top of multiple dictionary object which provides an ordered lookup. So inside the chain map, only the list of memory address of a given dictionary object to the constructor of a chain map is stored. It does not store all the elements which are provided in the form of dictionaries or the mapping. And for ordered lookup example, Python function looks up the variable or resolves the variable in a ordered manner. So first of all, it will look up in a local scope. If it is not found in the local scope, it will look for the global scope. So this is an example of an ordered lookup. So same ordered lookup we can implement using chain map. So let's take a look at the constructor of a chain map. So here is a constructor which takes variable amounts of argument as a maps or a dictionary object, and it returns the chain map object which is an updatable view. Okay, so here we will simulate the memory manager which provides the ordered lookup on the different kinds of memory: cache memory, random access memory, and SSD. Okay, all the memory are having different objects as a key and their memory address in particular memory as their value. Okay, so from this mapping or dictionary object, here we have provided inside the constructor of chain map, and it will return the chain map out of this all mapping. So let's execute it. As you can see here, chain map constructed from the given 3 dictionary objects. So if you want to access a particular object, we can access it using key. Okay, so here we can write it inside square bracket key or use the get method, which is having signature same as we saw for the dictionary. Okay, so let's access the object 1. So it provides the ordered lookup. So based on given order from left to right, it will search for the given key. So if we search for the object 1, it will first look up in the cache. If it is not there, then it will go for RAM, and even if it is not there, then it will go for the SSD. Okay, so here we are accessing object 1 which will be found from cache, so it will return this value. So let's execute it for both syntax. As we can see here, it is returning the cache value. Same way we can access for other objects too. Okay, so for object 5 here, if we see, it is not in cache but it is in RAM in ordered lookup, so it will return the same value as per the RAM. For object 8, it is only in SSD. Okay, so it will miss for the cache and RAM, and it will be picked up from SSD, so it will have same value as given in SSD. And for object 9, it will found from cache, so it is having value from cache. Next topic is accessing non-existing key. So if you try to access a key which is not existing out of any mapping using square bracket syntax, it will raise key error, which is same as we saw for the dictionary object. Okay, it will complain that given key does not exist inside any of the mappings. But using get method, it will not raise any error. It will return none by default. Okay, so here we can see it is returning none. And get method also take second argument as a default value. So after key, if you provide a default value, it will be returned when the given key is not found in any of the mapping. Okay, so if you execute it, as we can see, the default value is returned. Next topic is changing elements of mapping after creating a chain map. So here, after creating chain map, we can also modify the dictionary object. So if we are modifying any dictionary object after creating the chain map, whatever the change is made afterwards will be visible through the chain map. So if we execute after, so we have removed object 1 from the cache, which is a first mapping. So as we can see here, object 1 is removed from the chain map also, because it does not stores all the element of a given mapping inside the chain map object. Instead, what it does, it only stores memory address of the given dictionary object. Okay, so whenever you are modifying that object, you are pointing chain map to the same object. Okay, so when you are printing or accessing chain map after modifying that object, that new value will be accessible by default. With chain map, as we saw for the ordered lookup, it will search whenever we are searching for particular element, it will search through all of the mappings from beginning from left to right given in the constructor. Okay, so first here it is provided in cache, so it will look in the cache. Afterwards it will look in the RAM and SSD and so on. Okay, but when we are performing insertion, update or deletion, it only performs that operation on the first mapping only. So if we are try to modify this chain map object, it will only modify the first mapping. So for this example, it will only modify this cache dictionary object. Okay, if you try to modify this other value, it is not possible. Okay, so let's see the example. Here we have created memory manager and we are adding a new object. Okay, so it will be added to first mapping. Here we can see object 10 is added. Okay, before it was not present. And if we try to access cache, we can see here object 10 is added. Okay, so whenever you are modifying, adding or deleting a chain map object, it will modify the first mapping of that particular given all the mapping. So now let's update. So if the key of a new assigning element is already inside the first mapping, it will update the value. So here we are modifying object 1, so it will update the value of cache. Okay, as we can see here, object 1's value is modified for the cache. But if we are modifying value for key which is not present in first mapping, even though it is present here, we are modifying object 2. Even though it is present in second mapping here, it will not modify it. It will add a new element inside the first mapping. So let's execute it. As we can see here, object 2 is added to the cache. Okay, so if we access cache, as we can see here, object 2 is added. Okay, even though it was present for the RAM, it is not modifying that particular element. Next is deleting an element. It will only remove element from the first mapping. Okay, so we try to delete object 3. It will delete only from the first mapping, as we can see here. So second mapping remains as it is, even though it is having object 3. So while deleting, if the given key does not exist in first mapping, even though it is existing in other mapping, it will raise key error. Okay, so here as we can see, we are deleting object 2 which is present in second mapping, even though it will raise key error. It is not found in first mapping. Okay, now we will compare the functions of chain map with the dictionary. It is not subclass of a dictionary, but it shares the functionality with the dictionary class. So we will take the common functionality of both the classes. So if we execute the difference between sets of attributes of two classes, it will return the methods which are common between chain map and dictionary. So all these methods have same semantics and meaning for chain map, but only difference is it will only take effect on first mapping, as we saw for the updating of a chain map. So any modification, insert, update, delete, only modifies the first mapping. Okay, so we will see some example of these methods. So if you also take a look at all the methods of chain map, excluding the special methods, if we take a look at it provides similar methods to the dictionary. Okay, here, so we will take a look at some of the existing functionality which is common to the dictionary, and the new functions and attributes which are present inside the chain map. Okay, so for other functions it is same as the dictionary. Okay, so let's begin with attributes. So first attributes is maps, which returns the updatable listings of mapping. So it returns a data structure or the internal representation of a chain map, which is actually stored inside the chain map object, which is returned by the constructor. So as we have explained earlier, it stores the mapping inside the list. So it copies the memory address of given dictionaries inside the list, which can be accessible using maps attribute. Okay, so let's access the maps attribute of a memory manager. As you can see here, it is returning a list containing dictionaries as a elements. Okay, so this dictionary is not a copy of a particular dictionary which is given here, but it is the same object which is passed here. So if we modify one of the address inside the map list, it will take effect on the dictionary object. Okay, so let's first access those dictionary object using indexes. Okay, so as we can see here, if we access index 0, it is returning our cache object, and if we are accessing last index, which is third, it is returning SSD. Okay, so we can also reassign some of new mapping using this returned list. Okay, so if we have new mapping updated cache, we can replace the memory address which is stored at index 0 of a chain map object, which will replace the mapping of cache object with newly given dictionary object. Okay, so let's reassign or replace existing mapping at particular index. So if we execute it, as we can see, earlier it was having cache as a first dictionary. After updated cache, it is pointing to updated cache. Okay, same way, by accessing index of a particular map, we can also modify element of that particular map. Earlier we saw the function which were only applicable to the first mapping, but using maps attribute, we can access any indexed mapping or dictionary object, and using that dictionary object we can directly modify it. So here we are accessing first mapping, which is this RAM object, and we are adding a new key value pair. Okay, so let's execute it. As we can see here, the RAM object is modified and having value new element object 4. So if we try to access variable RAM, as we can see, it is returning same dictionary object. Next attribute is parents. It returns the new child map, chain map, containing all the mapping of existing chain map except the first one. So we have chain map and we execute parents, it will return a new chain map excluding the first dictionary or the mapping provided. So let's execute it. As we can see, it is returning from second mapping up to the end of the mapping. It only removing the first mapping. Okay. So next topic is functions of chain map. First function is items, which is similar to the dictionary. It returns item view on a chain map, but it will only returns element which are accessible using chain map. So here, as we can see, we have duplicates key value. Okay, so cache having object 3 and RAM is also having object 3. So RAM's object 3 is not accessible because whenever we try to access object 3, it will always return from cache. Okay, so it will, when we try to iterate over the items of chain map, it will not return object 3 which is not accessible. Okay, it will always return only object 3 as a this value. Okay, so we will take a look at an example. So let's iterate through each item. Okay, so as we can see here, it is iterating through all object and it is not repeating any object. Okay, so first object 1 here, object 2 from the RAM, object 3 from the cache, and object 9 from the cache. Okay, object 5 from the RAM, and so on. So based on the ordered access, whichever the object is accessible, it will return it. But duplicate objects which are not accessible using chain map are not written by the items view. So same items view can be collected into the any container. So here we are collecting inside the tuple container, so it will return all the elements inside the tuple container, which is having elements as a tuple object, inside it key and value as a element, and they are also the same, only the accessible elements through the chain map. Same way, keys and value, as we saw for the dictionary, it works same for the chain map, and we can also iterate over it or collect into the any container we want. So next function is pop, which takes one argument as a key and returns and removes the element from the chain map. Okay, so chain map, it only works on a first mapping or the dictionary object which is given. Okay, so if the given key is inside the first mapping, it will return and remove element from that mapping. Otherwise it will raise key error even though it is existing inside other mapping. Okay, same as we explained earlier, it will not go for the other mappings. Okay, so let's first pop the object 1 which is present in the first mapping cache. So as you can see, it is returning the value for object 1 here, and it is removed from the first mapping. So if we access it, that element is gone. So if you try to pop a key which is not inside first mapping, even though it is existing in other mapping, as we can see for object 2, it will raise key error. Okay, key is not found in first mapping, it must present in a first mapping. So it is also similar. So pop item method we saw for the dictionary, it works similar for the chain map too. Okay, now if you want to pop item from specific mapping, we can use maps attribute to retrieve indexed mapping from the internal structure. Okay, so as we have explained earlier, maps attribute return the list which is internally stored by the chain map object. So from that list we can retrieve any indexed mapping or dictionary object, and that dictionary object we can modify. So here we are retrieving first indexed dictionary which is RAM, and we are popping object 2, so it will remove object 2. Okay, so as we can see here, it is returning value for object 2 from the RAM, and after popping it is removed. And if we try to access variable, as we can also see, that variable, that element is removed. Okay. Next method is new child, which takes only one argument, which is optional. It returns new chain map attaching provided mapping as M in front of old chain map. So we have existing memory manager chain map, and we want to attach a new mapping in front of it. We can use new child, in which we will provide new mapping. So here we have L1 cache, and we want to attach it before the cache. Okay, so we can execute on existing chain map object new child L1 cache. So it will attach newly given mapping in front of old mapping. So as we can see here, first mapping is for new memory manager is L1 cache, second one is cache, third one is RAM, and fourth one is SSD. Okay, so that brings us to end of the video.